Okay, so this is a Form 4. It's a pretty good printer. I've been printing on it for 3 months. I haven't had any failures, and I've been really curious to see inside of it. This is Alec Rudd. He was and is the tech lead for Form 4. And so what we're going to do should be really interesting. We're going to take this thing apart, and I'm going to ask him how everything works, and we can get a really neat internal dive into the machine. And I have no idea what I'm going to see. So,
awesome.
And I'm going to do things that make you uncomfortable
Look
with
forward
this
to
machine.
it. Yeah.
So we've got an assortment of tools. How many hours did you spend developing this?
2.5 years times 10 hours a day, 5 days a week.
It's a lot
I'm
of
not going to do
hours.
that math on
Okay.
the,
All right, let's see how long it takes to tear it apart.
to break my spirit.
So we'll start with the back. Is this something a user would ever have to do?
Yeah, all of our main replaceable parts are accessible through, or most of our main replaceable parts are accessible through the back panel.
Do this?
Yeah, so you can take off that panel and they'll be able to replace the cartridge floor, the dispense assembly, the level sense, and the camera.
Is this for like, what is the little porthole for?
Yeah, so you can, we're gonna have a 3D printed adapter for hooking up to a ventilation system. So they have this small little lab scale ventilation systems you can hook up to.
I saw that on mine and I thought like, that connector must really stink. You have to be able to get to it to fix it or something. There's like, is that a Dashpot?
Yep, yeah.
Can you guys see this thing in here when this comes down? That little, it looks like a little shock absorber. Is that really necessary?
It's nice.
No slammy?
No slamming, yeah.
That's nice. What are they, is there something that those are used in normally? Like, why are they so affordable? Like VCRs or something?
They're probably, I'm actually not sure what the main industry is, but they're like readily available on most industrial
What would
websites.
that be? Like
Drawers for like soft close drawers. They have like more specialized ones, but it's a pretty similar.
So that's from drawers. That makes sense. There we go. Okay. Sorry. So this is probably the hardest injection molded part.
This is by far the hardest injection molded part.
This is crazy.
It's a lot of square, parallel faces, all cosmetic.
So it's 2 parts, right? So there's a well or a glue joint here.
Yeah, a little glue joint there. That's jigged at the factory and glued.
How long did someone spend trying to get this friction, hinge, everything working nice? Oh, and these are clutched.
Yeah, there's a one-way friction hinge. Yeah, so it's not really clutched, but it's really hard to push the other direction.
Oh, yeah, you can't. But they spin freely that way. What's the mechanism? Do you know what's inside there?
I haven't taken one apart. I'm not entirely sure what the mechanism is.
Like it's like a roller cam thing or something?
Yeah.
It doesn't seem, it's like a hinge. How much work could it take to make a hinge? But I bet someone spent like months just getting the right hinge, testing the slamming. They probably slammed the cover 10,000 times to make sure it doesn't break, that it doesn't wear out, that it feels premium, and that it doesn't cost a lot of money. And what's the purpose of this?
That helps guide the cartridge when you install it, so you don't get it to jam up on anything. It's just kind of like a poke-yoke feature.
So when the cartridge goes in, you can catch it here.
Yep.
So this is like a funnel
Yep.
to feed the cartridge down.
And it prevents you from inserting the cartridge backwards as well.
People will try.
People will try.
Yeah. People are really good at finding ways to get the machine to do things that you never even thought. On the Form 1, you could put the tank in reversed, which no one ever tried ever. And you could also put the build platform on upside down, which...
That's a fun one.
And then slam the cover on and break the cover. I don't know if anyone broke the cover, but you could. And then this is all new. So this is the cartridge. All the resin pours out of this, and it's really hard to make these because they make about 1 million of them. They can't leak when you're shipping. They get squished and stepped on and pressure changes, but ultimately it's pretty simple. So there's a bite valve or a rubber valve that you squeeze that lets liquid out, like a bite valve on
like a camelback. Yeah.
But this isn't stock. This is...
Yeah. So we developed our own bite valve. A lot of our resins are pretty high viscosity, so the stock bite valves you can buy don't flow the resin out fast enough. So we wanted to have a faster filling tank and be able to keep up with the print rate of the machine.
And then also like there's all this extra geometry. Is that for drips and?
Yeah, for drips and just to kind of help it all return back to its shape and seal itself.
I mean, it's crazy. Like we could probably talk about every part in here, and people have talked about every part in here for weeks to get it right and understand all the detail. And then how does it know when I put this in? How does it know what the material is?
Yep. So there's an RFID tag hidden under the sticker. You can see the outline of it. Yeah, you can rip it off. Oh, yep, there it is.
So this is what the cartridge sits on. So what are we seeing here? This is a scale, a little mini scale. So if I slam it, do I bend the load cell?
No, so there's a flexure on there that helps protect the load cell and keep it safe. And then there's...
Oh, I'm gonna
crunch the cartridge.
The thing you don't expect about these load cells, if you just hit them, they bend. It now says a cartridge weighs negative 20 kilograms or something like that. Just even in this little cell, there's a safety mechanism that will, if you overload it, it will bend down and then hit a hard stop so you don't break the load cell. What are they? Not Toyama, the little Japanese motors. Is that what you're using for the bite valve?
Yeah, it's a little DC geared motor.
See if we can get it out. Don't tell me.
I won't.
This guy out of here. So like something like this cartridge, bite valve, and the little motor that actuates it. How many people worked on that? How long did just that take?
Yeah, so we had like probably 2 main engineers working on that. We had somebody that was responsible for making sure that the cartridge was going to do everything it needed to do and design the bite valve. And then we had another person designing all of the mechanisms and printer integration. The cartridge itself and the bite valve was a good like few months of development to try to get everything right. We probably went through.
Seems pretty fast.
Yeah, it's probably more than.
I'm not
from
trying to call you out.
No, yeah.
Like really
from start
fast.
to finish, it was probably like 6 months for the bite valve, and then we did like more iterations after we thought we were done.
Well, yeah, I mean, you sent me a new cartridge floor on my beta, so like there's still bugs you're working out. And I'm probably doing this wrong, aren't I? Like I shouldn't do this. I should take off this first, maybe.
No, you can take it off from there.
How am I supposed to get to these?
You can take it off. Well, do you want me to tell you?
No.
Okay.
Oh, that's. Is this just a shroud? No, that's actually carrying the camera. Is this like the standard Raspberry Pi camera cable?
Yeah, that's a MIPI cable.
Nice. Yeah, this is a really cool. You can actually see the protection. So I worked on the Form 3. How many parts from the Form 3, if any, are being used in this machine?
Directly, almost none. Probably 0. No, we're using the leveling feet are the same. So we got one.
Those are off
we got
the
at
shelf,
least
though,
one.
aren't they?
Those are off the shelf.
Are they? They're hexagonal. I think we make those.
There's custom, yeah.
Okay.
Which I think is the same as the Form 2 feet. So.
This is the crazy flexural mechanism. Does it bottom out on here?
So it bottoms out on this nut. So it bottoms out on the other side, actually. Because this whole thing is going to be deflecting mostly vertically, so it'll short all the force to that nut.
So it's flexing around.
Yeah. Like almost flexes forward in a kind of unintuitive way.
Yeah. So that nut is exactly the right, I guess you designed it just to use a standard nut.
That's why we have like custom spacers and stuff to get everything.
I see. So the load cell sits here. If I body slam the cartridge down, this metal flexure will bend forward and hit that nut, and it'll keep us from deforming this aluminum. I assume this is aluminum, looks like aluminum. If you don't have this is like pro tip for other product engineers, it's not going to work very well in the field. All right, let's get this off. Is there any issues with, like thermals were always a big problem on machines. I mean, it makes load cells drift. Is there stuff that changes when you take it to like ice cold place or hot place? Was that an issue at all?
It's not a big issue. There is a little bit of load cell drift, not enough to really matter for what we're trying to measure. Yeah, so we have temperature sensors in the tank measuring resin temperature, so we're able to compensate for any cold environment. We test down to 18 C, I think. So that's pretty chill. That's like what, 55 Fahrenheit, something like that.
Yeah, it's
pretty cold.
Unheated garage.
Unheated garage, yeah.
I saw this on mine. I actually had no idea what this was for, but someone told me some guy designed.
Somebody designed little guitar picks.
Special shims for build platform. This is build platform leveling.
Yep, that's build platform leveling.
Is it also LCD swap or?
Yeah, after you swap an LCD, you want to kind of re-level the build platform. The Allen wrenches are for LCD swap. And you can also take out the back panel with those Allen wrenches. So you can do, I think, every major service loop with just the tools that...
So these 2 Allen keys and then the guitar picks.
Yep.
Does it guide you through on the user interface?
Yeah, for BP parallelism, it's a fully guided operation.
Is there anything else to rip out before we go to the front?
Rip out Sanic and camera.
Let's pull out Sanic. Sanic is code name for an ultrasonic level sense system. Another big problem with these machines is that you have to know when to stop pouring resin out of the cartridge. You can't just turn it on and hope for the best. So this board should be the thing that tells us how much resin is in the tank. So it's ultrasonic. What's the resolution?
Yeah, for like a stationary target, we can get like 1/4 millimeter usually.
Wow.
It's actually pretty high resolution.
Yeah.
It's a lot harder with the resin because it's like moving around and splashing and doing all sorts of stuff.
Well, with that mixer, it's like never...
It's never really level.
Are you using AI to tell you how
Unfortunately,
deep
no.
it
Actually,
actually
no.
is?
Fortunately, no, we're not using AI.
Is there any AI in this machine?
There's no AI in this machine,
What?
to my knowledge, yet.
Do you watch the news? No
We're afraid it's
AI.
going to take over and get us.
With the camera, there's definitely AI potential.
Yeah.
What's your favorite part of this machine?
I think the LCD module is the coolest. It has like the most technology packed into one single component.
So that's what we should get to.
Yeah, we should get to that. That's
Okay.
pretty fun to look at.
I want to see that. So this is RFID. So this
Yep.
is how you sense the tank.
Yep, that's for the tank.
Okay. So this is a little ultrasonic transducer. Sends out a pulse and then listens for it.
Yep.
Is it all custom?
It's all custom, yeah.
Yeah.
Yep.
Yeah, this is a Formlabs board. And that's how you're able to get 1/4 millimeter steady state. Or did you say 500 microns or?
Yeah, a 1/4 millimeter if we're just looking at a flat plane, and then a lot worse than that in like the millimeter-ish when
Pretty
we're
good.
doing moving resin.
I mean, just this little thing, I could see someone, that could be their job for a long time. And then we have a camera that's torxed in there. Is there a reason this is torx instead of hex?
Everything that's user replaceable is an Allen wrench.
So something that you shouldn't take off is torx.
Something you shouldn't take off is torxed, yeah.
Is there any security torx on here?
We have no security torques. Yeah, that was a little extreme for us.
Well, there might be something like, do not loosen this or it will like, you'll have to send it back. On the other machines, there was stuff if you loosened it,
You're
that
done.
was it.
Yeah.
Is there anything on this machine if I loosen it, like it's over?
No, pretty much every component is user replaceable and kind of expect it to be user replaced. So you can take it apart. We'll make you put it back together after this.
I'll never put it back together. Yeah. So this looks like a Raspberry Pi camera.
Yeah.
But then this is all custom. Is this custom or is this just a custom mount for it? Yeah, this is a Formlabs board.
Custom board, yeah. We have LEDs and stuff on there as well.
Where are the LEDs? Are they?
Right there.
Oh, there they are. So how long did it take to get this angle of the camera?
That was a lot of work.
I mean, it's like not square on any axis, twisted.
Yeah, that was a lot of mounting cameras on flexible arms and like repositioning and taking photos and repositioning and taking photos, and then looking in CAD and trying to have like angle cones so we can try to figure out what it's actually seeing.
Are the cameras consistent, the modules? Like, do they always point the same direction or is there any variability?
There's slight variability, but we always have everything in frame.
Okay, so do you crop, do you calibrate that or is it just?
We don't do any calibration for that right now. We just check to make sure everything's in focus.
That's a thing you actually check at the factory is does the camera focus and have everything in frame?
Yep.
This is a crazy little injection molded part. That's cool. Let's see. Pull it off. Oh yeah, it's Raspberry Pi. So this is like Raspberry Pi heart.
Yeah, it's such a good ecosystem that's like so mature.
All right, where should we go next? The front,
Do you wanna
maybe?
go to maybe the front
Let's
or
look
the
at
sides.
the BP. So this BP, ooh, is really cool. So there's something like this on Form 3, but you had to redesign it again. So what kind of magnets? Is this rare earth?
So there's a Halbach array. So this is a...
Okay. It's fine.
Very good.
So there's a Halbach array.
There's a Halbach array sheet magnet under here.
Uh-huh.
And then there are neodymium magnets under what we call the troughs, and that hold on to this is all sticky. and that holds onto the rods and keeps that from popping off, as you just demonstrated.
Yeah. So this is a magnetic stainless?
Yeah, it's a magnetic stainless. Yeah.
Okay.
Yeah.
This is aluminum. Or no, this is
also
the same
steel.
stainless. It's
Yep.
all spot welded.
Yeah, it's all laser welded.
Laser welded. Nice. And these are only laser welded right there.
Well, I think it's what on the other side too, isn't it? In that little.
Oh, it's
yeah,
laser
yeah,
welded to the rod. Okay.
Yeah.
Okay. I thought just
No, it's not just that one tiny face. Yeah.
how much, like, this seems like another really hard to tune thing. Like, how many versions of this did it take to get the like the magnetic, like, as presumably you ripped these off from too much force and you had to make the magnets stronger and stuff like that?
Yeah, I mean, luckily the Form 3 design was pretty mature and we were able to copy almost everything directly from the Form 3. We just kind of like repackaged it and made it fit Form 4.
Yeah, I mean, I was involved in that and it was painful. I remember, that's why I'm asking.
Doing that work for us.
I didn't do it, I was there. I
Jason.
remember the gnashing of teeth. It's painful, but good. There we go.
It is.
That's cool. It's very heavy. What is that, the Halbach array? That, like, why is it so, feel that? Is that normal?
Yeah, that's normal. Because it still is an aluminum extrusion and like a couple
Yeah.
magnets and some steel.
It must be the Halbach array.
Yeah.
That is a very useful thing. Did you guys design the sound too?
Very careful sound engineering. Yeah, yeah.
Did you get the thickness to get the right tone?
There was a lot of thickness tuning of that to make it so it doesn't warp and bend.
So this is another one of the deceptively challenging parts to get right. So this is the, what do you still call it, the dovetail?
Yeah, we call it the dovetail, the Z stage and the dovetail.
And so it locks the build platform down and it has to be square and stiff and like very difficult to make. And also, if you close the cover on this, you don't want it to punch a hole in the cover, right?
Yep.
So this is one, and you totally redesigned it for this machine, it looks like.
Yeah, ground up, yep.
And it looks adjustable. What is everything that this does? What's all the stuff in there?
Yeah, so we have a build platform detection switch. So there's actually an optical gate deep in there that you can't really see.
Deep in there.
You have a flashlight, you can probably.
Yep. So there's a little. So you push that in, breaks the beam.
Oh, this is the other direct Form 3 part, I think.
Okay.
But yeah, push that in, it breaks the beam, it tells you that your build platform's in place.
But it can only do that up top. So if I pull out the build platform really fast while it's coming down.
Yeah, then that's your fault. You
Well, I
shouldn't have done
can't
that.
because the cover has interlocks.
Yeah, you could open the cover, take the build platform off, and we wouldn't be able to detect that.
Was that tuned? Is this a?
That was tuned. Yeah, we tried to make that feel as nice as possible, and it's actually like
nice.
it was a lot more satisfying than I thought it was gonna be throughout development.
Whoop, that
falls
wasn't
off.
supposed to happen. So this is just a little injection molded piece, a little die cast piece, and so it shouldn't. No, it still does it. So that's just this piece flexing and snapping over that little die cast piece.
Yep.
And then, what is this? An overmolded?
Yeah. So this is all like an overmolded steel part because that's going to be under constant deflection. So a plastic one would have crept and would have changed its position too much.
So there's a big injection molding tool. Someone puts a piece of steel in, then they inject both these at the same time, or is it 2 steps?
Yeah, same time.
Same time? And then you have a piece of metal entombed. And then there's a bunch of details, like there's a little hole. Is that what keeps this? Does it go through the steel to lock this on the end?
The steel has a little bit of like a T shape to it.
Okay.
So it kind of like
Yeah.
wraps around that T shape so it can't pull itself off.
What's this little hole?
I'm actually not sure what that little hole is.
I see 2 ejectors, but the hole, that might actually be the support for the, that's what holds the metal. There's a pin that goes in
that's
there.
right.
And that,
That's right. Yeah.
I see it. Yeah, this is a cool part. Is this all nylon?
Yeah. That's all glass foam nylon.
Cool. Gosh, how long did this take to get designed and working?
This was like basically from the start of the program up until we started going to MPI. So that's
You
like a
were
full
iterating
2
on
years.
it?
Yeah, we're iterating
2
on it
years.
constantly. Yeah. Every time we change anything else in the printer, this had to change with it. So part of it was it getting tugged along with the rest of the design, but there's a lot of tuning to get all of these heights just right, make it so it's compatible with all of our resins, getting the BP scrape functional.
Yeah.
There's a
This
lot of
looks
tuning
like
that goes into that.
Yeah, this looks expensive. Is this all CNC'd, this whole thing? It's not an extrusion? Do you want to make it? Well, I guess there's not really much value to an extrusion, is there? It's
You end up
just a
doing so
bar.
much machining after extrusion. That's all.
But this is like the heart. I mean, this is critical. This is a really important. You didn't make it expensive for bling factor. You made it expensive because that's the only way that you could find to make it. And so this is all CNC machined, and then it has, is this heat staked? This?
Yeah, so that's a polypropylene injection molded flexure that's heat staked on at the factory.
That's cool. And then there's a whole, hold on, this way. So you've got, yeah, it's like, that's nice. Is there a reason not to have it forever attached?
Initially, we were like, oh, it'd be nice if you can clean this stuff separately, but we actually are going to change it to be forever attached.
Okay. I took it out and it like, or actually I was trying to like do something in the tank and it came off.
And then it's like really hard if you don't know how to, yeah. So we're going to fix that
I also
soon.
put it on backwards. Or no, how did I do it? I think I went through. I told you users find really dumb things to do. I think I put it on upside down like this and tried to slam it in and it went in, but it was sitting like this. I was like, that doesn't seem right.
That's probably not right.
Yeah. It would have detected it with the smarts. So this, I got distracted. So this also does leveling.
Yes.
Right.
This also does leveling.
And then there's a whole mechanism on here, which should we get that off? I guess we should get that off so we can look at it. But then we'll get to the LPU if we have time. I'm going too long. But there's so many parts. Nope, that's. And this whole thing here looks die cast? Is it die cast?
Yep, yeah. This base part's die cast, and then this is extruded.
Okay. Will I be able to get it off with the... oh, yeah, I can just... There we go. There's a lot of pieces in this. What's the, I guess we'll have to get that on camera, but what's the purpose of this little, the
little spring?
Does that hold two sides of the spring? Does the other side go in there?
Yep. Yeah, so it's like a little carabiner spring.
Oh, that's cool.
Yeah, it's like a little...
Did you just like take that from the carabiner? Was that the inspiration?
That was the inspiration for that spring, cool. Yeah.
That's really clever. We didn't do that before. And do these also push out or is it just the one side? No.
No, these are screwed in.
Is that a datum?
The datums are at the bottom here. And then that's really it. We don't do very precise control in theta Z. It doesn't really matter.
Yeah. See if I can get this out of here. Okay, there we go. Got it. That's in the printer now. But we're going to get in there and take it out. Wow. So this is the... Does it have to be that?
That beefy?
That beefy? I mean, that is crazy.
Yes, we want to keep everything as stiff as possible. So when we're printing with really viscous resins, you don't get the whole thing kind of clamshelling open. And this was one of the big areas where you have a big moment on that part.
What about the tower? Oh, you have a huge rail. Nice.
Yeah, we went to instead of the flat rails from the Form 3, which used a big old...
Yeah. Is that the same one that's on the 3L or is that...
It's not the same as the 3L. It's similar, yeah.
All right, so here's your little flag for B-roll purposes. What does this do? That's the end
flag.
stop. Yeah. Okay, so there's an optical sensor that detects this to home, and there's an optical sensor that detects this, and there's a build platform in it. This is a crazy die-cast part. Your cool carabiner spring. So what's actually moving to latch it?
The little drawbar there. Oh, there's down here.
Oh, oh, that's cool. So it's kind of like a milling machine or something. There's a drawbar that T-slots into this T-slot groove with this little round thing, and it pulls the build platform up against the dovetail. So it just locates it like that. Doesn't really care too much about rotationally.
Yep.
Just planar. Okay.
And it pulls it with like
There's a lot going on in there.
500 newtons or something. The preload on it's like pretty high.
Really high.
Yeah.
And then is that floating? Because like when it moves around. Okay, so that all moves with it. I see. So I was thinking if this moves and that's fixed to this, then
Right, you can never
the
get
preloads are all going to change.
Exactly, yeah. So all moves
How long
together.
did this?
That one, actually, if you go look at our original Proto 1 in the other room, it's very close to what this is right now.
You just nailed it.
Like
on the first
we did
try.
it pretty well. It took us like a couple of tries, and then it was small refinements to get the packaging smaller.
Wow.
But yeah, the team that worked on this did a really good job of getting it.
Yeah, and this is totally different than Form
Yeah.
3. Like this is completely all new. Like we didn't use a drawbar or anything. That's cool. All right, now the good part, LPU. I guess tank as well. So this is one of the probably deceptively simple.
It's one of the hard.
It looks simple, but it's really hard. How long did this, what looks like a piece of plastic, take?
We went through a lot of iterations on getting the steel ring right, getting all the heat staking right. We're holding the film under a lot of tension. So we have to be able to pull that tension and not have this whole thing like buckle and warp.
Like twist or something weird.
Yeah, yeah. So it took a lot of, this was like probably a year and a half to get this right. And then there's a whole production problem of doing that and then doing it consistently every single time.
Like, are you measuring the, like for every tank, do you measure how tight it is and everything?
Yep, yeah.
Did you have issues with creep? I guess that's why you have the metal ring.
So I have the metal ring. It's like kind of the backbone of the whole thing, yeah.
And did it, so you like, at the factory, you have to tension this evenly.
Yep.
Do you tension it with a circle? Or do you?
No, we tensioned it with two
axes?
Two axes, yeah. But we were really worried about that, and we were looking a lot at doing like a big circular ring. But we tested it with two axes, and it seemed to work fine, and we were able to do tension maps across the whole tank and make sure it's even and kind of what we expect.
And so you just heat stake it down. Is there any sealant, or is it just squeezed really hard?
Squeeze really hard, heat stake it down. Yeah, this whole thing is clamped in a giant press while it's being heat staked.
Wow. And presumably there's like an edge that it's bent around or something?
Yeah. There's like a capstan in there that the whole film is bent around to kind of give it a good sealing interface.
And then you've got, this is for the mixer
Yep.
What's the purpose of the cutouts?
It just reduces the stiffness of this.
Oh, okay.
Yeah.
So it can like preload against it?
Yep. Yeah, it sits flatter.
Did you have any issues with like ejecting resin with that super fast mixer?
Yeah, we actually spent a lot of time in the initial tank design trying to make sure it wouldn't eject resin. So we called that tsunamiing or geysering. Well, first it was tsunamiing, then we added tsunami deflectors, and then we realized that we were shooting resin out of this little hole here. So then that became a geyser.
Old Faithful?
Yeah, Old Faithful.
This is, because this is like a tsunami wall, whatever they have, the wave breaks on beaches, so it'll tries to redirect it back at itself.
Yep, yeah. You can like watch the resin in slow motion. We did a lot of slow motion footage when we were developing this. You could see the resin like hitting the wall, coming up and splashing back over and make sure all the resin stayed in the tank. It's really hard to move the wiper at, close to a meter a second, like 750 millimeters a second, back and forth without spraying resin everywhere.
And you're accelerating it really fast too. Do you know how many Gs you're?
We're doing about a G. We're doing 10,000 millimeters a second.
Doesn't sound like a lot, but a G is a ton. Yeah, that's like, that's pretty fast. G.
Yeah, I think this tool has like the most actions of any tool I've ever seen.
Yeah, because there's an action for every single one of these.
Yep.
So an action in the tool is like a moving part that allows you to create a feature that you wouldn't normally be able to do in an injection molding tool because it's undercut. You guys go through so many tanks in the prototype that you actually make an injection molding tool just for testing that you're going to throw away.
Yep.
Because otherwise you'd be spending hundreds of thousands of dollars on
machined or 3D printed or
And so you did that 2 or 3 times, and then you made the final one.
Then we made the final one, yeah.
Wow. So yeah, basically every part in here, there's like, it's the crazy thing. Every single part in here, there's someone who knows everything about that part, and if it changed at all, they're gonna like get upset and care and try to fix it, and there's a lot of parts, so it's amazing the amount of work that goes into these things. What about these little clippy things for the tank? Was that easy or hard?
That was also pretty hard. There's a lot of debate on how to do it. We had a lot of concepts that were like much more complicated and had like one lever that clamped the tank in. It was like really, really sleek. But we decided to go with just like Tupperware latches, we called them, just for reliability and robustness. And it kind of just
It's just a little
snaps
tiny
over.
snap fit.
Yep. And
Is there flexure in? Oh,
Yeah,
wait,
yeah.
these are spring loaded.
Those are spring loaded.
What?
Yep.
Okay, so you have a spring-loaded latch on like a sheet metal carrier, and that entire thing is spring-loaded up. So that sets the force down on the tank, and if you didn't have that, any variation in the tank, it wouldn't hold it snug and tight. It might be too hard. Did you try doing it without those springs, or?
We did some prototypes without the springs, and then, yeah, exactly what you said. Any variation made it so the feel was bad or tanks would come loose.
Did Max try to make you make it a flexure in the injection molded part?
No, fortunately, but he did want us to make it a flexure in the chassis. Right now, it's a separate piece of steel that comes up.
With springs, or is it a flexure?
It's just a flexure.
Oh, that's a flexure I'm pulling on.
Yep.
That's good.
Yeah, it's just a
that.
metal flexure. Yeah, it's gonna be hard to get to that.
Maybe you can like show. This won't take it out here. Oh, that's the side shell.
That's the side shell. Yeah.
All right,
We've like barely gotten into the machine.
Let's do that. Yeah, the all boring stuff. Let's do the LPU. It's not boring, but compared to the LPU, some might say it's boring. Not me. All right. So if I was a user and I dropped a dumbbell on my LCD, this is what I would be doing to replace it. These 8 screws. And there's a little, what's that? It's this little,
that's
a little thermoformed piece or something?
Yep, yeah, it's a little thermoform piece. It's a window. It's a window for an IR sensor.
Oh, okay. Like a thermopile?
Yep.
So that's how you sense the resin temperature.
That's how we sense the resin. Yeah, it looks up through that little window and it hits on the tank right about here. Yeah.
And it works on all colors of resins. There's they're all absorbed.
Yeah, it's actually measuring the tank film more than anything.
So it doesn't see through the tank.
It doesn't see through the tank, yeah.
So this tank looks black
to the IR.
To your 1 pixel camera.
To our 1 pixel camera.
Yeah. Cool. All right, so there's 8 screws. And I guess before we get into this, the top of this looks crazy. Is this glass? What is this material? Yeah,
so that's actually a plastic material. It's basically like a plastic micro lens array that we made. And it's hard coated with a special coating that prevents it from getting scratched, prevents the resin from sticking to it. So you could actually cure resin right on top of it and then just like peel it off. Which is pretty cool.
So a resin spill isn't catastrophic like it is with a lot of machines when you get it on there.
Yep.
All right, let's see if I can get this out. Don't tell me how. I've never read the instructions, so. I mean, my first instinct is just yank on it. So that's what I'm gonna do. With this. Hope this, oh, that was not so bad. Oh, wait. Okay, there's wire harnesses. So there's a power, and then this looks like a service loop. Okay. It's just a straight HDMI with like suspenders on it.
Yep. Little suspenders to make sure it doesn't get unplugged during shipping or so it doesn't get damaged as you're pulling it out.
Is that a problem you discovered the hard way, or?
No, that was a thing that we were just worried about. So we decided to just kind of belt and suspenders it from the get-go. Okay. And that's actually a fused SLS part.
Yeah, a little SLS part, little flexures that clip on, interface with the PCB. This is one of those surprisingly difficult to do things because you have to have your PCB with exactly the right cutouts and then like your print farm part all matching up perfectly. Although this is easy to iterate on at least.
Yeah.
Okay, so this is the LCD, right?
Yep.
And then We've got heaters. So this is just a circuit board with a long trace on it.
Yep. Long,
right?
Skinny trace, yeah.
And you just pump electricity into it and it gets real hot.
Yeah, pretty much. Pretty simple, yeah.
Connect positive, negative. Why is there so many conductors on them? Is that just a bunch of heaters in parallel, or in parallel, I guess?
Yeah, we also have, if you look there, we have a little temperature sensor on each of them.
Whoa. Okay, so 2 lines are going to the temperature sensor, but that still leaves a lot of other.
Yeah, then the other one is just redundant for.
So there's a heater on both sides, presumably, or is it just the one side?
These are single-sided. Yeah, these are single-sided. These are aluminum core single-sided.
Okay.
Yeah, these are the same board on both sides.
Okay. And why is it soldered? Why isn't there a connector?
It's just less expensive to just solder it directly there, yeah.
Surprising.
You can just hotbar solder, so you can just come in and do all of them at once.
Okay. And then this PCB is doing what? It's just passives for the temperature sensing and anything else? Do you know?
This is all the driver for the LCD.
To power it.
Yep.
Okay.
Yeah. And this PCB under it is.
And what's this surface here? Is this a datum?
Yep.
So this.
Yeah. So that registers onto the printer frame.
Okay. So that makes it always at the same height.
Yep.
Can I over torque these? Oh, those are a datum too.
Yep.
Okay.
Yeah.
Was there any problems with that, like getting this?
No, so there's actually, these are on little flexures in there. Okay. So the frame itself has little flexures, so you can preload it a set amount.
Yeah, which is that's the kind of thing I would expect to really be, like if you tried to just screw all these down to something rigid, it would probably like warp it, right?
That,
if this
pop
isn't
the glass
flat,
out, yeah.
Well, and it could make your LCD change. Like if you push on an LCD on an old calculator, it turns black, right? So
yeah, you get like some funny streaks where it's not working. Yeah.
And it's critical that this is consistent.
Consistent, flat, and not full of stress.
Yeah, no stress. Totally chill. And you said this is a lens array. Is this actually doing optical lensing?
We're trying to make it do as little optical lensing as possible while allowing as much airflow as possible. Those two things are kind of at odds. So there's a lot of work that was done.
I mean, it's definitely doing optical lensing.
Yeah, you can see.
But it's less the closer you get to it.
Yep.
Like I can see my hand just fine. Not so bad. Pretty bad, actually. There we go. There. Gets worse. My face is all messed up. And it's that far away. So that looks like a really annoying part to prototype. Like, how long did this take?
It took us, we went through, I don't know how many dozens of iterations of trying to prototype this. We had the idea, we had the concept, we thought it would work, but we had no way to actually test it. So we spent as much time trying to figure out how to do the first prototypes as we did like getting the final design right. It was months
like
of iteration.
Was just how do I even make this?
Half the time was, how do we even like prototype it to prove out that it can do what we want it to do? And that was a big combination of like 3D printed jigs and fixtures and presses and stuff.
Yeah, and then once you were able to make it, you were saying it was then dozens of iterations to.
Yeah, once we could make it, we did dozens of iterations in-house because the tooling to make a part like that's really expensive. It's really long lead time, so we wanted to get it right the first time. So we did lots of iterations in-house so we could make as many, do as much testing on it as possible before we shipped, or before we locked the tool design down.
Okay. I don't think there's anything else to take off here because it's basically glued in, right?
That's all potted in, yeah.
What is this? Is this silicone?
That's silicone just to seal it, yeah.
Okay.
Yeah.
I see, and there's so you have a gap, that's where the airflow comes in through here, through those. What's the purpose of this gasketing?
We don't want any resin if you did have a spill, to fall down into the printer. So we try to keep
so you have
this section sealed.
You have an elaborate gutter system and sealing to keep resin out. Does it, if resin goes in here, does it then go downstream somewhere else, or does it just go over? Yeah, does it just pool in here?
It pools, and then there's actually a drain right there, and it'll end up going down into this cavity.
Is there a catch thing?
There's no real catch, but it's fairly free of the things that will get damaged, or it's stuff that's really easy to replace.
Yeah, this is another one of the things that it's easy to overlook, but it's like where if it shouldn't and it doesn't,
Yes.
never happens. But if it did, just theoretically, where would the resin go if I dumped a liter into this machine?
It's really fun to test.
Yeah, the first time. It's not fun to clean up, I'm sure. But so you guys thought all that through. The resin comes down, goes over here, and goes out this dedicated spout in the injection molded part down to a safe space, and then onto your desk.
And then on, dude, hopefully not.
That'd be a big, I don't think I've really seen a spill that big outside of our testing in the field. Maybe like when a bite valve came off or something.
Yeah.
But it's very rare, very, very rare. But you're covered. Okay, so what next? Look at the size of this rail. That looks expensive. Is that a big part of the bill of materials, this rail?
It's actually not that big. This is a pretty common rail size.
Oh, okay.
So they're made in such high quantities that
You can get it.
you can get them for relatively
nice.
cheap. Yeah.
Oh, there's the screws. Wow, exposed fasteners on the outside.
That was also a big.
I'm a little surprised. Was there great arguments about these
There
screws?
are great arguments about these screws, about what color this should be, because it's not the same color as the rest of the part.
Yes.
Yeah, but we got every detail just perfect.
Everyone cares about their stuff very much. These are good debates to have.
Yeah.
Because it's always a challenge, like what's cheap, what's easy, what looks nice. Those are very rarely the same thing. What's easy to use.
There's no tension in like your development process. You probably just like made a bad product.
Yeah, if there's not great debates. So this is just sheet metal powder coat or
Powder coat, yep.
It's an interesting powder coat. It's metallic. Why not? That's aluminum, right?
That's
feels
aluminum. Yeah.
So why not anodized?
Anodization is hard to get consistent over like many runs of or many batches of parts.
So like this won't match that.
That won't match that.
If you don't do them at the exact same time.
Yep, yeah. And then this part is die cast, so you can't anodize it and have it look good.
You can try. Yeah, it's not going to look.
Do your
very
best,
nice.
but it's going to be bad.
Why does your motor have tails?
Those are just fan mounts, so they're like anti-vibration fan mounts.
So you just like squeeze the fan onto them like a. Okay.
Like a Go-Gurt tube.
That's funny. But all that extra material is being wasted. Shouldn't they be half the...
Yeah. Yeah.
The cost down opportunity here, you make these half as long. That's actually really clever. Hey, those quarters of a cents add up. 4 quarters of a cent. There's 4 of them.
4 cents.
All right, so you've got a very large fan.
Yep.
So this presumably is for cooling.
Yep.
And all the high power stuff, optics, presumably, not electronics.
Yeah, cooling the optics. Yeah, we're putting so much optical power through the LCD that there's a good amount of waste heat generated. So we have to try to dissipate it. It's really challenging because like you can't block this, obviously. You can't put something here to block it. So you have to just blow air across it and try to get enough convection to pull all the heat away.
Did you look at different materials to try to get better convection, better heat transfer?
Yeah, we did. We were always joking around about like having texture on the bottom side to increase turbulence, increase surface area. But that isn't great for, for optics.
Printing.
Yeah.
Did someone run a CFD of the airflow to try to make it even? And
we did CFDs. We did smoke testing with like literal smoke. We blew sick vape clouds into the printer.
How hot does it get if you don't cool it? Does it just kill it?
It kills it. Yeah. If you're printing if you're printing fast at full power without any cooling, it'll get up to like 80, 90, or 100 C. It gets pretty hot.
Yeah. And you've got a big filter. Is that user serviceable?
Yep. Yeah, you can take the panel off and this should just pull right out.
Oh, nice. Nice little filter. So there's your mixer. If I move this back and forth really fast, can I power it up? Can I make it boot?
You can try.
You could do that with the Form 2.
You could
when you
pick
run
them up by the...
Yeah, and it'll turn on.
Turns on by the time it drops.
Do you know if you have stuff to prevent that backdriving?
I'm not sure, actually. We can try it.
That's a great Easter egg. I'm just going to unscrew these. I don't even know what these go to. Oh, it's coming off. They have like white Loctite on them or something. Okay. What on earth? All right, we'll get to that. Is that the end stop for the mixer? That's what that looks like to me. You feel it? Yeah, that's the end stop. So that's a beam. That's a beam break for this. That's how you know where to stop, right?
Yep, that's how we know what the limit is and
Okay.
what we use to home.
So otherwise, the motor doesn't know where it is. So like if I put it here, it has no idea. So when you start it, it has to go until it detects that, right?
Yep.
Okay.
There's a couple other Easter eggs in there that you'll have to take the front panel off to get to.
Front panel next. Cut that. We'll do this fast. So we've got a Raspberry Pi screwed to a big Formlabs board. But is that a custom Raspberry? Like, what is that?
That's the Raspberry Pi CM4.
What what does CM stand for?
Compute module.
Okay, so that's trying to be like a system on module kind of thing.
Exactly, yeah, yeah.
So they sell this to companies like...
Yep, yeah, they have a bunch of different configurations of it.
Wow.
And they sell it to companies and yeah.
I didn't know that's smart, Raspberry Pi. I didn't know they did that. I guess I don't need to rip the Raspberry Pi off.
Yeah.
We'll leave it there.
That'd be great.
Okay, I won't rip the Raspberry Pi off. There's man, the cable routing looks like a lot of work to get right. Is there like just one big harness, or are these all separate?
These are all separate. Yeah, okay. They end up getting like zip tied together in various places, but yeah, we don't have one massive harness. Yeah.
Do they work with you to integrate this, or is that you just got it, has a data sheet, and you just do it?
Yeah, we got it and just did it. Yep. And then we all the memory and everything is on our board. So if we had to replace the CM4 for any reason, because that's like the most complicated, error-prone part.
So you push as much not changing expensive parts off it so that you can replace just that if you have to. Is that user replaceable?
That's user replaceable.
Wow.
Yeah.
Okay. Was that a consideration, HDMI cable versus?
Yeah. We want something that the user would be comfortable replacing if they needed to. All these little tiny LCD cables are really delicate, really easy to break. I've broken probably more than I'm happy about.
Yeah.
So yeah, we want to make everything HDMI.
Is this a custom HDMI cable that's exactly the right length, or did it just happen to work?
It's custom to be.
Of course it is.
Yeah.
Yeah. Wow. This is the motor for the mixer. Stepper. That's pretty big. Is that just the forces of, like if you want to go fast in viscous materials, you need high force?
Yep, exactly. Yeah.
Is it on a vibration mount? No?
Nope, it's just solidly mounted.
Not a problem. All right, and then the front panel. Wow, okay. So how much thought went into panel attachment and like architecture because you can see there's like crazy, the way this front panel attaches is pretty interesting with these, I don't even know what you'd call that, slots with screws that almost pivot.
Yeah, so we're pretty conscious about panel gaps. We want to have everything as like tight as possible, like just for aesthetics. So there's a lot of thought into like how you assemble it and how you get this front panel aligned to your side panels in the factory. So there's a lot of thought. Slides tight to the side panels. Yeah.
Whoa.
It's not those.
Sheet metal truss, like this. Hold on.
Oh yeah.
Is this just because you could? This is what I am seeing here. Hold on. Is that right? Oh, that really doesn't feel right. Okay, there it goes.
There it goes, yeah. Yeah, so we try to.
This is your ultra lightweighting for the
yeah,
machine.
It's made of Drillium. Yeah, this is trying to keep everything as light as possible for shipping. Didn't save all that much, but it was pretty cheap to do once you tool that part.
So there's a stamping tool that does this?
Yeah.
I feel a burr. It must be.
There will be a stamping tool that does this.
Okay.
Yeah.
Yeah, these look laser cut. So this closes up the mixer so that it looks nice.
Yep, and it prevents resin from falling down into it. So this has a
Yeah.
big overlap with that.
If resin gets onto this rail, again, thinking through all of the ways resin can go down and everywhere, should something that never happens, yeah, think through all this. This is a gutter thing or an awning.
It's like an awning, yeah. Or it's like this is the awning and this is the like undercut of the awning.
Yeah, it's a double awning.
Yeah. I honestly don't know why.
Probably just like display power and
Oh yeah, it's
signal conditioning or something.
Gosh. You get to pop.
Oh, it's the lever.
Yeah.
That'll do it. Oh, you have an encoder. Wow.
I was wondering if you're going to notice that,
Okay.
yeah.
Very cool. So this is a stepper.
It's a stepper, yep.
You're using the encoder to detect stalling early?
Yep, yeah. So if we run into it, if a part falls off, which it never does.
But if it did, theoretically,
yeah, we'd run into the part, it would stop the motor and we'd be able to detect it with the encoder.
And that's so that you don't have to go all the way back.
Yeah.
Because you could detect it just by homing at every layer, but you don't want to do that.
Yeah, if you watch when it does motion, we do what we call mixer dodging, where it peels and does a synchronized motion with the wiper or with the mixer. So we wouldn't be able to do that safely if we didn't have
I see.
crash detection. Yeah.
Is that like a special tiny quadrature module for this?
Yeah.
Wow. That's cool. Yeah, that's nice, using the same PCB for both light-based thingies. There we go, we can actually look at it. Whoa. Are these solder-on mounts on the PCB?
Yep.
That's cool. So you have two sets of vias, and you just solder these lugs on, and then that mounts to the frame. That's nice. Instead of a piece of sheet metal. But someone probably spent a long time thinking about if you should have a piece of sheet metal or these lugs or something.
Like loose nuts or something else.
Yeah.
This makes it just easier to service too, so you can just take out screws and not worry about dropping nuts into your printer.
Yeah. And they're upside down, so resin, I don't know.
Resin can't get onto them. Yeah.
Better than right side up, I guess. Cool. And you tension the belt for the slots. Okay. What's in here? Oh, power supply?
Power supply, yeah.
So this is like a certification double insulation thing?
Yeah. So it's like a
Off the
fire
shelf.
safe enclosure. Yeah.
And this fan is for cooling the power supply. So all your air comes in here. You have some sucked up in here. And then you also pull some
Out that way, yeah.
This doesn't suck air through are these cordoned off? Are they both pulling air from there?
They're both pulling air from there, yeah. It doesn't suck back through here. Yeah.
But if this fan fails, you're going to suck dust in.
You're going to potentially suck stuff.
So this fan overpowers. This is like an axial blower, yeah. And so there's a whole ducting system here to get your flow. And the air shoots out, and then where does it go? Down, cools so you're using the hot air to cool your electronics?
Yep, yeah. The air doesn't actually get all that hot.
So high flow.
Because it's so high flow, exactly, yeah. So it comes and sweeps over the electronics, and then it can exit out, just kind of generally out the seams in the back of the machine. Well, there's an explicit hole in the back of the machine. Yeah. So when you take off that cover.
Whoa. Magnet,
yeah.
is that really necessary?
It looks good though, doesn't it?
Why does it need to come off?
So you can clean it if you wanted to. So it's like, we call this like the cat hair filter. So it prevents anything from like really getting in there and clogging up.
But air's coming out, or this is the this is the inlet. I see.
It's inlet,
Okay.
yeah.
Okay. Let's see if we can get this
BLU.
BLU out. So you have another large fan with a big heat sink. So this is for the LEDs themselves, I'm presuming.
Yep.
Let me get this off so we can see it. Oh, a little speaker. Oh.
Speakers?
Oh no. Oh no. Bear with me. It's the one with 2 wires probably. Yeah. There we go. Got it. The one part from Form 2 and 3. I think it's the Costas.
Yeah. So you didn't have to take that off to get this out, but
What's the purpose of this piece of sheet metal? Just holding the fan?
Yeah, it just holds the fan in.
And I guess it directs the airflow.
Yep.
So is this cooling all custom?
Yeah, this is all custom cooling. So it's a custom heatsink that's underneath here. And then, yeah, we're sucking in through the grate and then pushing out on either side of the machine.
How much thermal design went into this?
A good amount, yeah. There's a lot of math, a lot of simulations. We didn't want to, have to tool this big part and then have to redo it a bunch of times. So we wanted to get it right the first time.
Is it an extrusion or is
Yeah, it's just a big aluminum extrusion.
Okay, yeah. I mean, it sure looks like an extrusion. And then post-machined, you have to take an enormous amount of waste heat away because they get super hot. But then the light from them is also a lot of energy, so it makes the LCD super hot because it's probably absorbing more than 90% of the light energy.
About 90, yeah.
Okay, that's pretty good. And then, so that gets hot. It can work, but then die early, presumably, exactly, if it's too hot. So you probably did you do a lot of testing?
Yep, we did a ton of lifetime testing of both the LC itself. So that was, blasting them with light, getting them hot, putting them in ovens, measuring them continuously over the course of many months, and making sure that they were going to last. And then once you do like integration testing of bringing the whole thing together and making sure that you didn't just break a cooling loop by accident by putting a panel where you weren't supposed to put a panel, or putting a wire in the way that blocks flow.
Whoa! Oh, and you have alignment pins for this too. Is this really alignment pins?
There were talks about doing fancier calibration at some point.
Oh, I see. So if you want to do light distribution, calibration, and stuff, okay. Plastic molded, custom, I assume. Yep. Optics.
Custom optics.
Power, and then we've got what's fan? Okay. So fan is separate, and that's it. Ugh. There's a diffuser. That's custom too? Yeah, that's all. So is this an injection?
Yeah, I think that would end up being an injection mold.
Flat sheet,
just
injection
flat
mold,
sheet, yeah.
but to get the texture and the shape and everything.
Yeah, and because it was we already knew what acrylic resin and stuff what we wanted for it. So either you have to go extrude those for us, or we just injection mold it. So
yeah, and the whole frame. This is the last thing I guess we're gonna dig into. But then another challenge you talked about it being stiff and the forces. So when you peel, you yank up on the build platform. So you have the build platform that wants to twist. This whole tower wants to bend, and this is like is this an extrusion, or what is this tower?
The tower itself is an extrusion.
Okay.
These are just cosmetic sheet metal kind of fascia panels to hide the cartridge and hide everything else.
The extrusion. So there's a really stiff, thick aluminum extrusion. I mean, thin-walled, but thick section to be stiff. And then that's bolted to what looks like 2 pieces of sheet metal with like a square around it.
Yeah, it's basically like a sheet metal box. Yeah.
Oh, yeah, and this also closes it nicely. Yeah. So there's 5 sides on it, except for the top. And so that's a very stiff shape, and really the main force that you'd see. Yeah,
we bolt in from this direction onto the tower. So we're grabbing it in, I think, 4 locations along the Z-axis. So it kind of helps to prevent it from twisting itself open or torquing itself open.
Yeah,
like clamshell or whatever. Yeah.
And it doesn't have to be super square because the build platform is adjustable, right?
Exactly. Yeah,
so
we want to be
not crazy to assemble.
Yep.
You don't have to put a micrometer on it and square it up or anything. You just bolt it.
Yeah, we don't need to go crazy. We need to make sure it's square enough that you don't have your whole Z-axis drifting over the course of the print.
Isn't that calibrated?
That can be calibrated out. It's not, but
it's not anymore. We used to.
You get weird pixel things though, because you're if you have a straight wall, you're traversing pixels when you do that. So
I'm not even gonna bother to get in there, but there's a force sensor that looks really similar to the Form 3 force sensor.
I think the spring is actually the same part, and the PCBA is the same electrical design, but just kind of changed around to make it fit.
This actually force senses differently than the cartridge. There's a spring that the whole motor can move up and down on, and then there's inductive sensor.
Inductive sensor,
right? Yeah. So it detects the gap between the top of the motor or the spring, and there's like a target or something.
Yeah, there's a little target on the motor itself, and it moves up and down and detects that distance.
And so when you pull on the build platform, the motor will get pushed or pulled on, and so then you can see how much force you're applying to the part. So you know, is there a failure? Did it rip the tank? You know,
are we about to break something? Yep.
Yeah.
Yeah. And we do like very fast control loops to make sure that we're not gonna apply a ton of force through the LCD screen.
Yeah. Yeah, that's like the worst thing you could do.
Yeah.
This is taped together. That's interesting. Why not screws?
Well, you can see we put spots for screws, but we would have had to modify the
Extrusion.
this tool. That's another plastic tool. Yeah.
You can't screw through to this.
We could have, but the tape we did
works.
initially, and it worked fine. So we said, let's just keep with the tape.
Nice.
Is there any concern with it working under the heat or anything?
Yeah, so we did testing to make sure that it would be stable under temp. That was a big concern. Make sure we didn't like buckle or change the distance to the LEDs or anything.
So what made this part? You said this was a really hard part. What made it hard?
I mean, the optical design is tough, right? Designing a lens is difficult, and designing a lens that gets 60 LEDs to have a uniform power distribution is really difficult.
Do you actually achieve that?
I mean, it's not perfectly uniform,
Yeah.
but it's a fairly uniform end result.
Wow. Wow, that's a lot thicker than I was expecting.
And we have to get all these lenslets centered over every one of those LEDs. There's actually, it's flexurely located. So these pins help to get it kind of like averaged out above each LED.
So, okay. So these little pins go into holes on the lens, but they're flexible.
They're flexible, yeah, so if you push them. So like the elastic average of all of those pins makes the lens as centered as we can get it over every LED.
You don't try to push it.
We don't try to push it to, or like locate against a hard edge or anything.
This must get super hot too.
That gets fairly hot. Yeah, I gotta do more thermal testing on that.
So you've got, man, those are really small LEDs. Are they 365 or
405.
405? Really? Was that to keep resin compatibility?
Yeah, most resin compatibility.
Was that another big decision? Which wavelength is?
That was a really big decision, yeah. So it's resin compatibility and then also LCD lifetime. The lower wavelengths will degrade your LCDs a lot faster. So we wanted to make sure that we had as long a lifetime as possible, and we didn't want to destroy resin compatibility.
That was probably not something that there's data on. You just had to do a lot of testing.
Yeah, we did some testing on it to make sure that what we thought was going to be true was true, and yeah, it turns out it was.
What you thought was true was true.
Yeah, always that's when that happens.
Yeah. When you tried to make this, so you said, all right, we have our theoretical lens array. How long did it take from when you had that to when you had like working ones mass like out of the tool?
Yeah, so we actually tooled just a single lens first, and we made tiled single lenses that we could like kind of get located properly. So that was actually that's like probably like 6 weeks or something to get the first ones from like start design and getting our first letters lit.
Were they diamond turned or was it molded?
They were molded, yeah. So we had to go make a bunch of them to make one array.
Yeah, it's expensive.
Yeah.
Another part where it's cheaper to tool it.
Yeah, so you were to do a small tool.
And a diffuser on the back. Yeah. But then this final part was like, this thing needs to be flat, right? This is really tight. Like all these have to be right, and it has to be very, very flat. I messed. So it's warped, you'll get crazy.
Yeah, your optics just won't be what you designed it to, right? Yeah, all your distances are allowed and focal lengths are wrong.
Well, what's your favorite? What was like the best? I think you said. Did you say it was the ELE or this?
There's this. Yeah.
This. That's the heart and soul.
This is the heart and soul. This is like we simplified a lot of complicated early prototypes into just a solid state optomechanical component that reduces scale forces and gives us like really good free quality. So it's pretty cool to be able to take a lot of like really complicated electromechanical systems and just like maybe something solid state.
Is the signal inverse? Like it's transparent now, so you're telling it, does it flip the signal?
Like you're giving it like white images and black background.
Because normally a LCD is off, right?
Depends on.
Depends.
Yeah.
Okay, I'm not an LCD guy. Every single one of these things you have to check to make sure it works, is what you're saying. So
Yep.
even if you're not calibrating, you have to do it to make sure, like, the cable's not disconnected.
Exactly. Yeah.
Yeah.
Even the fans, right? We have to turn the fans on, make sure they spin up.
Do they just listen? How do you know?
These all have tachometers in them, so we
Oh, okay.
get
You get
feedback.
feedback.
Yeah.
Well, thanks for sharing all the juicy details.
Yeah. Thanks for tearing down
Very
the machine.
interesting stuff. I could maybe reassemble it. Oh, but that's gonna happen.